Hello everyone. So this side Anu and me and Akshit is going to present this topic about Azure Function App Accelerator with event-driven architecture. So the agenda of this to understand how the agenda is to understand uh, how the function app works and what is the reason why function app, how it works, and how we can build event-driven architecture using function app. Okay, so let's get started on that. So the first thing is that okay, we are going to cover these pointers. What is why we function app, how do we build event-driven architecture with function app, and how do we make the function app template-driven? Like we can have a template for specific needs of the system design, and then we can use that templates in order to build up the function app in real time in no time. Like it's like bootstrapping it and sending to the production or getting it ready for the production in no time. Okay, so why function app? So quickly talking about it, those who are familiar with AWS or other clouds, you might have heard of lambdas. In other, we have in Google Cloud, we have different Google Cloud functions. In Azure, we have function app, right? But what it does, so basically, it's an abstraction. The name is given as function app. What it does, most of the things like related to infrastructure, etc., is handled by cloud itself, and it actually trigger based. Something is a trigger, like it could be an event, HTTP request, or something like that. So it listens to that event and it spins up. It spins up the instance and it makes use of the CPU. It makes use of the memory. It completes the task. It completes the execution of the function, and then yeah. So that is the function app. So over here, as I already told, that most of the things are done by cloud. So we are responsible for writing the function. So here the function is not about single function like writing a small function. It's about set of functions that coordinate with each other and that completes a single task. Okay, so that is the function app. And yeah, so what are the key features? Basically, as we mentioned, like as soon as the request lands, it spins up and it executes the task, completes the task, and done, right? So scalability is one of that key feature where number of requests lands on basis on the demand it works. So it does not keeps on running like we have the VM machines which keeps on running. Even if there is no request, they keeps on running and incur you a lot of cost. But here we basis on the request, as it spins up, it makes use of the CPU, memory, and accordingly, according to the usage, the cost is charged by the cloud. Okay, so that is the scalability. Second is again the pay as you go goes along with that. So which says that okay, I will execute once I get the request. So I will not be always be executing. So there we have some cost saving. But yeah, there is also a trade-off when the number of requests are more, then obviously the function apps needs to spin up, and there is a lot of instances of the function app that runs, which cost a bit. So event driven again, so it is trigger based as I told earlier, HTTP request, timers, queues, and more. So those triggers will happen and the function apps gets involved. So yeah, and the microservices architecture, basically we can build, we can have multiple function apps talking to each other, and each of these function app or set of functions represent a microservice which are responsible for a particular task. Like I can have a function app for payment operations, right? I can have a function app for booking an order. I can have a function app for triggering a lead, right? Sales lead. So all of these like constitute a microservices architecture using the function app. So that can also be done. And then the integration with, so Azure provides a lot of integrations with the function app. It integrates with a lot of other services, databases, etc. Then and the use cases. Let's talk about the use cases. Real-time data processing nowadays, like we have IoT devices, or real-time metrics like GPS navigation systems running within the transport vehicles, etc. So if those are sending out the events, like in terms of database, it goes to the IoT solution within the cloud, and those events can trigger the function app to do some processing. So that way we can do real-time processing. Serverless APIs, basically, again, serverless, when I say that behind the scene there is a server, but we don't have control on it. We do only take care of the dev part. So serverless is, that's why we call it as serverless APIs. Whatever the APIs we expose via function app is known as serverless APIs. So this is the use case. So we can build REST APIs on top of function apps, and then we can use it. And automated workflows, like we can build a workflow that okay, by going through a certain checks and conditions, it goes through a workflows. It checks whether that should send out an email or notification or push notification, etc. basis on the workflow. Okay, we can build a workflow using FunctionApp. Using logic apps, there is a solution. So we can integrate the function apps in those logic apps within the Azure. So file processing, like again, if we have suppose some end user is uploading a file which is very huge, right? And you want to chunk it down and we want to process it to a WebP image or some optimized image and store it somewhere in the cloud storage, then we can make use of the function app. So function app can take the request, it will process it, resize the image and optimize it and store it into the another cloud storage. That is file processing. Then we have integration and ETL. So basically we can do the ETL kind of processing. We have the operation data sitting in the data source, and then we can make use of the function app to load the data from the data source and then send it to the cloud storage or some other destination store. So all these are the use cases. There are a lot of use cases. So yeah, so one of them are this. So most of the things are already covered in the previous slides. We already talked about this is serverless. Lightweight means lightweight in terms of cost, in terms of footprints. All these are easy to write and deploy. Basically, we just have to write the code and deploy it, and the underlying infrastructure is taken care by the cloud. We fast to execute, although it is debatable, like whether we have complex logic within it or we have a lightweight logic. So it executes fast. Basically, we tend to create lightweight functions rather than complex functions. So that's why it fast to execute. It loads fast basis on the cloud infrastructure, and execution is triggered based. Event is fired, whether it is HTTP request or event. It auto scales basically. If we have suppose the number of requests are getting increased, so it scales itself accordingly, and there is no need of infrastructure. Means like we are not, we don't have to worry about creating infrastructure or provisioning anything ourselves. This is done by the cloud itself, and then Azure Function app or can also be built using the Azure console. We can make use of the browser to update, edit, or upload the function app. And then we are easy to upgrade the function app. Okay. And yeah, so these are the pros of and uses of the Azure function. And most of these pros are applicable across the cloud. It is not specific to Azure. There are certain properties which is specific to the function only, and there are certain things that Azure has provided us as a benefit. Okay. Now, how do we use the function app for building up the event-driven architecture? So what is event-driven architecture? Basically, normally when we write a code in HTTP REST API-based solution, two systems talk to each other by making request reply pattern, where we say that, okay, I sent the request and I am waiting for the response to arrive. So the consuming party, the other party, is going to send the response back, then only it will use. So this is request reply pattern. And the second pattern is you fire and forget pattern. You send the request, the other party will take the receiving party will take the request and it processes it. It store it some event hub or Kafka, and then later on those who are consumer of the Kafka, it is like a letterbox system, right? Somebody send a send a letter into the post box, and some other person take out the post from the post box and then do the processing, right? So here the letterbox is nothing but event hub or Kafka. You send the request to Kafka or event hub, and the consuming party will simply take the request from the post box or letterbox or whatever you can say it as Kafka or broker, event hub, or RabbitMQ, whatever. So you take that request from it and process it. So don't have to wait for the response to arrive. And this is what the on a high level event driven system is. And what is the benefit? Like we are complete decoupling. We have loosely coupled components. So there is no direct coupling. I don't have to take the code of the other and use it as a library or something like that. I just have to push the messages within the broker, within the queue system, and then wait for then it does not wait. It processes, the other party processes the request, and then you will be able to fetch the response in a separate call. Okay, so systems are loosely coupled. So there is no coupling between the two, like two libraries or something, two system or two components. Okay. So and scalability is there. Like we have a broker sitting in between. So you can have n number of producer who can send the message to the broker, to the central middleware, and n number of consumers can consume those messages from the middleware. That way the system is scalable. So we can keep on adding the consumer, we can keep on adding the producer. So there is no coupling between the two. So there is a scalability comes with the event-driven architecture. But of course, there are some pros along with there are some cons as well. It's difficult to debug certain things. There is no sequencing of things happening within the event-driven system. So those needs to be designed carefully. Like transaction is one of the concern. We normally see it as we make use of the saga pattern, etc. in the event-driven architecture, etc. So that's not so so what we are saying that let us build the event-driven architecture using the function app. So other is the real-time processing. Like I told you earlier that there is a IoT devices or some events. So we can ingest it into the broker and there are consumers who can consume it. And each of these consumer can be the function app. Okay. And fault tolerance, like basically we have some sort system, middleware system, which receives the messages. Suppose the consumer is down for some reason. So there is a persistency within the broker, within the middleware, who can keep your messages for certain number of for certain time. It could be max of 7 days or something, and then we can again fetch the event or message from the middleware and reprocess it, right? So systems are resilient. So and we can have multiple middleware servers who can receive the messages, and the consumer accordingly, once it brings up again, it can reread the message from the middleware and process it. So that way we have a resilient system. Even our system is broken, our system still works and can continue from where it left. Okay. So that is fault tolerant. So these are the components of event-driven architecture where I already talked about it. We have event producer who is responsible for sending the message. Event ingestion is nothing but a broker, Kafka, Event Hub, or a letterbox or post box, whatever, post office. You can assume it a central place, a set of servers where messages are going to be ingested, and there are set of consumers, set of processors. You can think who is going to receive that message from the middleman and then process it. Okay, so assuming this example as event producer as set of cars driving in Delhi region or Delhi NCR or in India region, they are going to give us the navigation like in the Uber system, right? So we have a lot of cars on the road. They keep on giving us the GPS details, right? So those details are being sent by the event producer. So they are treated as event producer. Okay. So event ingestion is going to be done within the Kafka. Kafka is the market leader in this. So although we have lightweight queue system as well, basis on the requirement, we have to choose RabbitMQ, etc. So event ingestion is done in the Azure environment. We have Event Hub, Event Grid, Service Broker, etc. So each has their own pros and cons, etc. So we have to choose accordingly. So all those messages produced by the producer will get into the event ingestion, and the consumer will consume it. Consumer here is like, I want to read those messages, and we can filter those invalid event information. Like suppose one car is sending 10 events and 10 location events, and out of 10, 9 is correct and 10th is incorrect. So those kind of filtration we can do. We can store those events into the database. So all this processing is done within the event consumer. Okay. And in this case, the event consumers are basically function apps. If I relate with the function app driven, event driven architecture. Okay. A producer could also be function app, and the consumer could also be function app. So yeah. So these are the example I've already talked about. Event ingestion, I already covered that. It could be a pub subsystem like a Redis, or messaging queue, Event Hub, Kafka, RabbitMQ. Those are Event Hub. This is a crucial part of the event-driven system. And consumer could be updating a database, triggering a business process, notifying the user. So this I've already covered in the previous slide. Yeah. So yes, this is a high-level diagram where we talk about how we can leverage, how we can build the event-driven architecture using the function app in the Azure cloud. So if you see, we have left side, we have devices. It could be device, it could be a customer, it could be anyone who is responsible for interacting with the system. Okay, as it interact with the system, it sends out an event. It could be an Alexa or sitting in your home who is going to send the event, right? So it sends the event. So Event Hub in the Azure cloud is going to receive the events, and then as soon as the Event Hub is getting the event, so it triggers the function app. The function app has the functionality to receive the event from the Event Hub or HTTP request, etc. Okay, so FunctionApp will take that request and then process that request and store that data into the Cosmos DB. And if there is some events which it could not process or there is some exception while processing, then we are going to send those events into the dead letter queue, like storage queue, so that we can later on debug what is the cause of the problem, what is the cause of the uh, uh, issue, exception that we need to fix, right? So, and along with that, we can make use of the CI/CD pipelines in order to deploy the solution into the cloud. And then we can attach it to the end-to-end monitoring system. It could be a application inside or open telemetry based. We can attach open telemetry and then send the metrics to Dynatrace or New Relic or whatsoever is the observability system we want to use. So that way, it gives us quite a good flexibility in the Azure cloud, that that number of integrations we can do. It also has an integration with Dapper as well. So that we can also use along with the FunctionApp. So it's the time to demo. So I am going to hand over to Akshit to share the start giving the demo of the FunctionApp, how to build the FunctionApp, and how we can create a template for the FunctionApp in the real time. Thank you.
Thanks, Anu. Thanks for this informative presentation. So most of the part you already covered, but demo is also important. So let's start with the demo. Let me share the screen first. Okay, so screen is visible, right?
Yeah, Akshit.
Okay, thanks, Anu. So in this demo, first we will see how we will create Azure FunctionApp. Then we will deploy the Azure FunctionApp to Azure Cloud using Visual Studio. And finally, we will see how we can create FunctionApp Accelerator. So let's start with the demo. So screen is visible or not at all?
It's coming up. It's still black.
Okay.
Can you reshare? Try. It's coming. Yeah, now it's visible. Yeah.
Okay. So let's create. Let's first create a Azure FunctionApp. Let's see how we can create a FunctionApp. Okay, so just open a new tab. Okay, so just we have to create a new project. Okay, so you can select here like which app you want to create. So here you can see the Azure Function App. So just click on the Azure Function App, and here you have to set up the project name and select the location. Then click on the next. Okay, so here you can choose the version .NET version. So you can choose like .NET 7 or 6. And here functions. So you can choose, there are a lot of functions like HTTP trigger function, event hub trigger, blob trigger. So anyone which you want to work with that function you can choose. So here I will choose HTTP trigger. Okay, so authorization level. You can also select the authorization level, like it will be authorized with only functions. It can be anonymous, it can be admin. Okay, so for now I will choose anonymous. Okay, so just click on create. So here you can see a complete project is created with filling some information, just basic information like project name, version, and all. So you can we can also say that it is also a accelerator. We just fill some information and a project is created, right? So I already created a project. So let's open that. Yeah, so I created it as name FunctionApp Accelerator. So before dive into the code, let's see the flow of this code with the help of diagram, flow diagram, right? So here in this FunctionApp Accelerator, we have two APIs, one for async that is denoted here with the red line, one and when the async receives the request on the async API handler, it sends that event in to event hub, and event hub
Akshit, your
async
voice
event
is
handler.
breaking.
Basically async API handler receive a request and then it will create a event and send to event hub, and that
So
event
yeah,
handler that will consume that event from the event hub. Yeah.
yeah, Akshit, your voice is
Now,
breaking. Yeah, can I cover that quickly?
yeah, just give me one.
Yeah, basically, guys, what we are doing here, we have two flows shown here with yellow arrow and the red arrow. So yellow arrow shows that we are triggering HTTP, like there is a HTTP REST call we are making for the function app directly. The second red line is showing that we are first of all triggering the function app. That function app and that function app is going to send the event to the event hub, and then the other event then the other function app is going to listen to that event from the event hub, act as a consumer of the event hub, and process that event and send the data into the Cosmos DB. So they both the flow Akshit is going to show as accelerator. Over to
Okay,
you, Akshit.
so I think, yeah, now it is better.
Yeah.
Yeah, okay. So let's dive into the code. Okay. So here we have two APIs. Basically, one is async API and second is sync API handler, right? So in async API, okay, so in async API, basically first we have a private uh, private field logger. Basically, it is used for the for logging purpose. And then second, we created a constructor of the class that takes an iLogger factory as a parameter, and it initializes the logger field with the logger created for the async API handler class. Then next we have a run method. Run method for the Azure function that annotated with the function attribute here, right? So you can see this is the HTTP trigger that basically it is a post request with the route v1/async. Okay, so first in the code, first we are checking with the null request is null or not, and second we are reading the request body using the stream reader, and then basically we are using the event helper class to send the events to event hub. So let's see what is in how it works. Event helper class, let's click on it. Okay, so here in event helper class we have one method, send event. Basically in send event method, first we are calling the get event hub producer that returns us the event hub producer client. Basically it contains the two values, event hub connection history and the event hub name. So we are calling it using the environment variable. Okay, so these environments, all the environments is defined into local settings here, right? Okay, so yeah, so once we receive the client, then it will create a batch. So first it is creating a batch, and then we are adding the event data into this batch. So we can add multiple events in this batch and send to event hub, right? But right now I'm just add a single event here and sending to the sending to the event hub, right? So go back. Yeah. So here once it sends through the event hub, right? It basis on the response, it will return create a response. If it returns an error, uh, so it will uh, create a error response here, right? So yeah, so once it it sends the events to the event hub, then our receiver, or we can see consumer, that is event hub trigger will receive that event. So the class name is async event handler. So once our event is produced to the event hub, then this trigger will be called and consume that event, right? So here first we will check the event is null or not. Then uh, like uh, we can receive multiple events. So that's why we are using here for each. So it will process those events one by one. And here we are calling Cosmos helper class. So in Cosmos helper class, yeah. So in Cosmos helper class, we it is basically holding the configuration information for the for connecting to the Azure Cosmos DB. So basically, it contains endpoint URL, primary keys, database ID, container ID. So first, we have here a save event method. Basically, it will first create an instance of the Cosmos client using the specified endpoint URLs and the primary key. And second, it calls create database if not exist method. Basically, it ensure the existence of the specified data and container. If they don't exist, it will create one, right? So next, we are using event data class. Basically, in event data class, we have three fields: ID, event ID, and data. Okay, so and in last, finally, we called say event to Cosmos method to send the events to Cosmos DB. So once yeah, so this is the flow of asynchronous call. Now, if we received a synchronous call, then we are not sending it. So basically, this is a synchronous call. So we are not sending it to event hub. We are directly saving the data into Cosmos without like sending the events to in event hub like we are doing in mm, asynchronous call, right? So here we are not using that. We are directly saving. First, we will read the body and directly call the Cosmos helper class and save the uh, request body, right? So this is the overall flow of the code. So let's first deploy this application to the Azure. Okay, so for that, first we have to click on the right of the function app. Then here you can see we are not using any CI/CD pipeline here. We just directly deploy it using the Visual Studio, right? So just click on the publish. Yeah. So here we have 3-4 targets like Azure Docker Container Registry. You can publish your application to an supported container registry that works with the Docker image. Publish your application to a local folder or file share. Publish your application to the Microsoft Cloud. So we will use the Azure. Right? So just click on Azure. Yeah. So here you can choose the function app like for Windows, for Linux, for container. Right. So here we will choose the function app for Windows. Okay, just click on it. Okay. So first you have to select your Microsoft account here. So I'm using the free trial account. So let's put it. Okay. So just click on the create new. I didn't have already created not created one. So let me check. Okay, already have one. Okay, so let's create new one. Okay, just click on the create new. So here you can see it automatically filled all the details here. So now, okay, let me check it again. Yeah, just click on it. Already it is created. Click on finish. So yeah, you can share. It is creating the profile. So yeah, so it automatically created the service dependency here, like a application site and the Azure storage. Okay, so now we are ready to publish. Just click on to publish. So let's wait couple of minutes. Okay, so let's wait for it. So we can discuss like the structure of this project, right? So we have the program.cs file here. So basically, it is the entry point of the application, right? So next, local setting, local store settings store JSON. So here we added uh, all our connection strings, environment variables, right? And next we have the host JSON. So basically, this file is a configuration file that allows you to configure various settings related to the host or runtime behavior of your Azure function. So basically, it is used for the global setting that apply to your all function with a function app. And here is a git ignore file. So in properties, we have launch settings. We are set up here the launch settings for local service dependencies. Basically, we can set here like to connect with services like Azure Web Job Storage and Application Insight. And next, so in dependency, we have all packages that we are using here. So we can also see in the .cs close file. So basically here here we are defined like framework version and Azure function version and all the packages, right? And like which file we have to use, like host JSON local settings. So we are defined all things here in the function app accelerator.csprose file. So let's see what project is published or not. Okay, so it is published. So let's see on the Azure portal. Okay, so here just search for the Azure functions. Function app. Okay, so yeah, you can see here one function app is created with the name function app accelerator. Right, just click on it. Yeah. So here you can see we have two APIs, async trigger and sync trigger. So you can see here it is added, and we also have one event handler. So you can see the trigger, HTTP trigger, event hub trigger, and HTTP trigger, right? So now to before run this, we have to set up the configuration file. So here we will set all the connection strings. Just go to local settings. So event hub connection string is added. Let's add one more. Event hub name. So test event. So this is last Cosmos key. Okay, now whole connection string is added. Now just we have to save it. Okay, so now we have to just restart it to reflect the changes. Okay, so now we will trigger one by one both the APIs. So just click on the async trigger function and you can see here get function URL. So you can get the URL of this function here and just okay, so we can also see the live logs, right? So first click on the monitor. So here you can see the live metrics, live logs here. So I will go to directly the Postman and will hit this API. Yeah, so here I change the message, hello event hub, and now I will send. Click on the send. Yeah, So you can see the status 200, and we received also a message event sent successfully. So now let's go and check the logs. Yeah. So you can see HTTP trigger function processed a request here, right? And now, yeah. So now we will check in first. We will check the event that this event is received or not. So here we have event demo namespace, and in this namespace we have one event hub. So here just click on the event hub. So here we have event hub name attached to event hub. Okay, you can also see the graph that we received one request, right? So for seeing the events, just click on the process data and click on the enable real insight for events. So here we can see all the events that we send here. Like just click on the test query. Okay, so let's wait for a couple of seconds. And okay, let's run again. Okay, so actually I'm using the free trial account, so it is not giving me permission to showing the uh, uh, events, right?
Sure,
So
sure.
let's yeah. So let's check in the Cosmos DB. It already saved in the Cosmos, so we are using demo test name, and in demo test namespace we have the collection. Just load it. Okay, so we have the database .001, and in the database we have one collection event store, and in the items yeah, so in the items we have the entries. So yeah, so this is that we send, and it's saved in the Cosmos. You can see the message like that we send hello event hub. So this is the flow of asynchronous call. Now let's set the synchronous call. Just remove the async and change to sync. Okay, so hello world. Okay, so let's hit this synchronous call, synchronous API. Yeah, so we got 200. Okay, so let's check it is saved in Cosmos DB or not. Yeah, so we have two entries now. It is 3, and you can see the message hello world. Okay, so this is the overall flow that we already discussed in the flow diagram also. So now we will see how to create a accelerator. Before creating a accelerator, we will see why we need a accelerator, right? So let's.
Akshay, I just want to jump, just to quickly jumping before accelerator. Let us
Mhm.
summarize it. So in this case, in
Yes,
this
yes.
flow demo, what we have covered so far, because just want to make sure that the people who are listening to us understood what is function app, how do we build it, and what the Azure has given us the capability to build it up,
Mhm.
and what was the challenge, right? That why do we
Sure.
need to go to the accelerator?
Sure, sure. So let's see why we need a Azure Function App Accelerator. So first is like development productivity. So accelerators or tools that it is enhance the development productivity often provides the features like code scaffolding, snips, and shortcuts. So basically, these tools aims to reduce the time of developers uh, that they spend on their routine tasks, and allowing them to focus on the core logic of their application. Basically, it will give you a complete project structure, right? So you have to just write your core logic there. Just in starting, we see when we create a new Azure function app, you see that trigger function is created there, right? We have to just add our logic into that trigger, and we can run that trigger, right? And it also increase the productivity that can result from features such as code completion, debugging, assistance, and the integrating testing tools, right? So second, template and the code generation. So basically, code generation tool can be valuable in speeding up the development. They can help the creating boilerplate code templates or scaffolding for common patterns or structure in your application. For Azure Function, code generation might involve creating the function templates, input output bindings, and other necessary configuration to streamline the development process. Right. Next, integration with the Visual Studio features. So, integrating with the Visual Studio, or it can be like a other IDE also. It is crucial for many developers as it provides a familiar and powerful interface. Like it provides the features such as debugging, profiling, and code analysis tool within Visual Studio that can enhance the development experience and also help to identify and resolve the issue more efficiently. So, and automate deployment and management, right? So automated deployment tools can significantly simplify the process of deploying Azure function and other resources to the Azure cloud. And like we have CI/CD pipelines that can be set up to the automate the build, testing, and deployment phases, right? So, a like when we create a project, all right, we need to write a CI/CD pipeline to continuous integration and the deployment. But if we like create an accelerator and add those pipelines into that, and just so other can use that accelerator, so that will be easy. Like they don't need to write new CI/CD pipeline. Just they will make some changes and they can use it efficiently, right? So best practices and guidance for the accelerator. So development accelerators often come with the best practice and guidance baked in. The many include templates and configuration that align with the industry best practices, so ensuring that developers follow recommended pattern for security, scalability, and maintainability. So having these type of guidance integrated into the development process, that can be helped less experienced developer also, like, so they can follow established principle without having an actively seek out the different documentation. So this is also the creating the this is also the best advantage to creating the accelerator. Like uh, other less experienced developer, they can use that directly that accelerators and mm, follow that best practices, right, and guidance. So that's why we need the Azure Function App Accelerator. So let's see how we can create Function App Accelerator using Visual Studio Code. So for that, we just need to select, yeah, just right click on the solution, and here we have to add new project. Okay, so for creating the accelerator, we need V6. So V6 basically it creates a extension, Visual Studio extension that we can share everywhere, and they can use that extension, and they can install into Visual Studio Code, and they can create the projects using the using that extension, right? So just click on the empty V6 project here. Okay, so function app demo accelerator. Okay, so just click on, yes, just click on the create. Yeah, so you can see here one V6 template is empty, V6 template is created here. So first we have to go, just click on the right. Okay, so for that just we have to first export that uh, complete application. So first we need to export this. So just click on the project, and here export template. Yes, function of accelerator save. Yeah, so here we will select the function app accelerator and click on the next. Just click on finish. Promote. Okay, so it is already exist. Okay, let me delete that file first. Okay, so let's rename this file. Yeah, so click on just finish. So here you can see and the function app accelerator AG file is created here. Let's export this. Okay, extract. Okay, so just delete this. Go to in the folder. So yeah, you can see here my template.vs template is created here. Just copy it to make a solution file. Just paste it here, and we need one more icon template. Yeah, so just copy it and paste it outside. Yeah, so now just need to create an empty folder. Function app demo accelerator, right? Okay, so now just add all the files. Okay, let's wait. Before adding it, just need to update this function name accelerator demo, and you can add also the description like demo of function app save this file and go back to the exploratory template. So now we have to just move it into FunctionApp demo accelerator folder. Okay, so now we have to create a zip file for this. Okay, so you can see zip file is created. Now go back to the Visual Studio. Now, so this is that we created the empty v6 template here. So just click on the v6 manifest. So here just change the name, author name, empty v6 file. You can add the description here. Okay, so just simply you can also add like other detail, license icons, tags and all things. Right, so just go to the assets. So here just click on the new. You have to select first select the project template, then you have to select file on file system and just click on the browse and add that zip file. uh, just add that zip file here. So let me check where it is. I'm copying this path. Yeah, so just click on this file. So here FunctionApp demo accelerator.zip file is added. Just click on the copy. Okay, so here it is added. Now just save this and set this function, set this v6 project as a starting project. Okay, set as a startup project. So okay, now and just run it. Okay, there is some build error. Okay, let me check. So here you can see that here is the extension is created, FunctionApp accelerator HTTP triggered example, right? So we can click on this and create the new project also. But before that, let's see in the that in the v6 file. Just let me open that. Okay. Yeah, FunctionApp demo accelerators. So here in bin folder in debug. So here you can see FunctionApp demo accelerator extension is created, right? So just click on it and it will install in the Visual Studio. So for install it, we need to close the Visual Studio first. Yeah, so just click on the install. takes a couple of minutes. Okay, yeah, so still one tab is still open, Azure at exe. So we need to close this one also. It is failed to install. Let me check what is the issue. Okay, so let's run it again. So it is rebuilt successfully. Let's add it again. So just click on delete it, and again we will add that file. So file is added. Now just run it again. So we have okay, so it is not able to extract this file. Okay. You have to just rename it as so let's create it again. We will create a zip file of this function. Okay. So now again we will add a new zip file. it is facing actually some issue to extracting that file, but although the extension file is already created, right? We can see it in the Visual Studio. So let's check it. Yeah. So here, just click on the create a new project. Okay, so just click on function app accelerator, right? So that extends. So just click on it. Yeah, right. So function app accelerator 1, just rename it like example 1 2, and just click on the create. Could not be found within the project. Let's continue to run.
Yeah, Akshit, can we wrap it up? Like we already shooting up the time.
Yeah, no.
So where are
Just
we as of now? Okay.
just we are creating a project using the function app accelerator.
Okay, so it's showing up somewhere.
Yes. The project directory already exists. When the project is created, okay, it is already created.
Might be while creating a project using function accelerator, you are choosing the same directory and same name of the project.
Yes. Yes. Click on the create. So here, using the function app accelerator, we have created a new project. So you can see all like whatever in the function app accelerator. So in function app accelerator example, in this project also the same things, like same code is published there. Like let's load it. You can see the API async API handler. So that same code is here. So we just use that accelerator extension and create any project using that extension, right? So yeah, so how this is how we can create a V6 extension or accelerator using the Visual Studio Code.
Yeah, so yeah, Akshit, let me summarize quickly. So guys, in this discussion, what we understood, why do we build a function app? What is the need of function app? How the Azure cloud is enabling us to build the function app in the Azure cloud? What all integrations Azure cloud gives us as a capability? And if we have a complex requirement or any requirement which is basically we need to build up on top of the templates that we can drive our product faster into the market. So then we can make use of the accelerator, and Visual Studio gives us the good capability by which we can create a template, we can create a Wix file, and then use it as a we can install it, and we within the organization, whomsoever wants to start with creating a new function app for a particular project, we can make use of that template. Yeah, that is the overall agenda of learning about how do we build accelerator in the function app and then leveraging it for building up the event driven architecture. So yeah, so that's it from our side. So although we have shoot it up like 20 minutes past, which is uh, but if we will be sharing up the questionnaire like Himanshu is going to talk about that.
Yeah. Okay. So thank you, Anup and Akshay, for delivering the session. Guys, if you're having any questions, though we are very though we are running late prior to this session, and we need to wrap up as soon as early. So if by chance you're having any queries, then you can completely ask Anup and Akshay. And if you're not, then surely you can reach out to them later on the Teams.
Right. Feel free to reach out, guys. And it's not about the function app in Azure. It's a function, overall a function as a service within the cloud. If you have any question in other clouds as well, feel free to reach out.
Okay, considering the silence, I guess no one is having any queries as of now. So it's fine. So thank you for the coaches delivering the session, and thank you all the attendees for joining the session. You all will be getting an assessment link after this session, and as well as a feedback form. Okay, with this, I'll just call it off. Thank you, guys.
Thank you guys for joining and listening to us.
Thank you.
Yeah, thank you guys for joining.